Okay, good morning class. So today we'll be discussing a new topic, combination of thin lens. As the question states, what is an equivalent lens? Obtain an expression for the effective focal length of two thin lenses placed in contact coaxially with each other. So an equivalent lens is a single lens which forms the image of an object at the same position as is formed by combination of lenses. What does this mean? Suppose you have two lenses. This is my lens L1. This is my second lens L2. If you have two lenses and you have an object O, the ray starting from the object undergoes refraction by these two lenses L1 and L2 and forms the image at I. Is it clear? Next, let us consider a different lens, but this time only one lens. And what happens? The object forms the image at I. So can you notice the difference? In the first case, we had only one lens. In the second case, we have two lenses. And both of them form the image at the same distance. This forms the image at V. So also this one forms the final image at V. So both of them forms the image at the same distance. In such cases, your single lens or your lens L will be the equivalent lens of L1 and L2. Single lens which forms the image of an object at same position as is formed by the combination of lens. Is it clear? Okay, what is the next part of the question? Obtain an expression for the effective focal length of two thin lenses placed in contact coaxially with each other. Next, what we have to do, we have to derive the relation for the two lenses, lens L1 and L2, which are placed coaxially along this axis. Clear? Coaxially means when you keep your lens like this, close to each other. Coaxially with each other. Clear? We have to derive the relation when the two lenses are placed close to each other. Now, let L1 and L2 be the two thin lenses of focal length f1 and f2 respectively, placed coaxially in contact with one another. Let O be the point on principal axis. You have two lenses, your lens L1 and your lens L2. The lens L1 has a focal length f1. The lens L2 has a focal length f2. Clear? There is a point object. This O is your point object which is placed on your principal axis. Is it clear? To derive this relation, we will consider two cases. The case 1 will be for the lens L1 and the case 2 will be for your lens L2. Now, for your lens L1, let OC1 equals to U. OC1, this distance, be the object distance small u. In the absence of the second lens L2, the first lens L1 will form a real image I dash of object O at distance C1 I dash equal to V dash using thin lens formula. Okay. Now consider your lens L1 only. Fine. This point, center of curvature, this is C1. This distance is your object distance small u. Okay. Now in the absence of your second lens, we will consider only your first lens L1. This lens forms a real image at I dash. Clear? This forms a real image at I dash. And at what distance it forms the final image? At V. Is it clear? So using thin lens formula, I can write 1 by f1. What is f1? f1 is the focal length for your first lens, equals to 1 by v dash. Image distance, where is my image formed by the first lens? At I dash, which will be v dash. The image is formed at I dash, which is v dash. Is it clear? Minus 1 by u. What is u? U is your object distance. Where is my object placed? At O. Is it clear? This will be my first case. So give equation 1. Now adding equation 1 and 2. On the right hand side part, what do you have? 1 by f1 and 1 by f2. So I'll write 1 by f1 plus 1 by f2. On the other side of the equation, I have 1 by v dash minus u, 1 by v dash minus u plus 1 by v minus 1 by v dash plus 1 by v minus 1 by v dash. I have added my equation 1 and equation 2. Now look here carefully. 1 by v dash and 1 by v dash are the same term, so I can cancel them out. So what am I left with? 1 by v minus 1 by u. So 1 by f1 plus 1 by f2 equals to 1 by v minus 1 by u. So I can write 1 by f1 plus 1 by f2 equals to 1 by v minus 1 by u. Give this one as equation 3. Okay, now for the combination of thin lens in contact, if f is the focal length of the equivalent lens, okay, of the equivalent lens. Okay, now we know from the equivalent lens, suppose you had two lenses. These two lenses can be replaced by a single lens. These two lenses can be replaced by a single lens. This single lens has a equivalent focal length of how much? Small f. This equivalent lens has a focal length of f, and it has an image distance v and an object distance u. So using our thin lens formula, can I write 1 by v minus 1 by u equals to 1 by f? Clear? 1 by v minus 1 by u equals to 1 by f. Now from equations 3 and 4, we remember our equation 3. What was equation 3? 1 by f1 plus 1 by f2 equals to 1 by v minus 1 by u. This one was my equation 3. And what is equation 4? 1 by f equals to 1 by v minus 1 by u. This is my equation 4. Now look at the right hand side part. Are they same? Yes. If they are same, can I write 1 by f equals to this part, 1 by f1 plus 1 by f2? Yes. Therefore, from equation 3 and 4, we find 1 by f equals to 1 by f1 plus 1 by f2. Clear? Now, in my previous lecture, I've already explained you the power, your P equals to 1 by f. Power equals to 1 by f. So 1 by f will be, P1 will be how much? 1 by f1. What will be P2? 1 by f2. So can I write instead of 1 by fp? 1 by f1 I can write P1. 1 by f2 I can write P2. Isn't it? So equivalent power will be P equals to P1 plus P2. Is it clear? So this is for two lenses. Now if we have n number of lenses, in that case what you'll do, you'll write 1 by f equals to 1 by f1 plus 1 by f2 plus 1 by 3 and so on till fn. Similarly, for power, you can write P equals to P1, P2, P3 and so on till Pn. Clear? Where P1 is the power of your first lens, P2 is the power of your second lens, P3 is the power of your third lens and so on. Is it clear? If you have any confusion, you can ask. Fine. Now coming to our next question. Why do we use lens in combination in optical instruments? Write an expression for the total magnification produced by the combination of lenses. Answer is, the purpose of using lens combination is to magnify an image. Suppose you have a small image formed by your first lens. If you want to increase the size of the image, what you'll do? Introduce one more lens so that the magnification increases. Is it clear? Next, to increase the sharpness of the final image. How will you increase the sharpness of the final image? By introducing your second lens, which will remove the chromatic aberrations. Clear? Next one is your to erect the final image. Okay, sometimes you have seen your lenses forms your image in the downward direction. What you can do is you can add one more lens so that the image is formed in the upward direction to erect the final image, and finally to increase the field of view. Clear? To increase the degree up to which a human eye can see. Fine. Coming to the next part of the question, we will write down the total magnification produced by the combination of lenses. The total magnification produced, this small m, can be written as m equals to m1 into m2 into m3 and so on, where m1 will be the magnification produced by your first lens, m2 will be the magnification produced by your second lens, and m3 will be the magnification produced by the third lens. If there's any confusion, you can ask. So that's it for today's class. Thank you.